So hello everyone, very good evening or very good morning or very good night. So today we are going to start our new series of complex analysis. Okay, in MMP we are going to start our complex analysis. So in complex analysis, what we start with? We start with the imaginary part because we know how to deal with real parts. In complex analysis, we especially pay attention on the imaginary part of the numbers. So we know imaginary part is iota and iota is under root minus 1. In complex analysis, we use the variable z, which is combination of real and imaginary part. Okay, so an argon plane will be there and z equal to r e to power iota theta, which is called the polar form of the complex numbers. And if we open it, cos theta plus iota sin theta and r will be there. So z equal to under root x square plus y square, which is equal to r, and same is under root x plus square, the value of r. Now if we determine the theta angle, which is called as argument of z, represented by argz, which will be tan inverse y by x, and theta will be 0 to 2 pi. Okay, now complex form of this z will be x minus iota y, represented by d star or z bar, and you can clearly see z and z bar will be z square, which is equal to r square s square plus y square. Okay, and you can clearly see the modulus of x will always be less than or equal to z, and y similar with y. It means the real and imaginary part of z will always be less than of z, which is very true because z is combination of x plus iota y. So x and iota y will always be less than or equal to z. If the imaginary part is 0, then z equal to x. If the real part is 0, then z equal to y. Now triangle equality. Suppose there are two sides of the triangle, then sum of the two sides will always be less than or equal to the sum of individual sides. Third side of the triangle will always be less than or equal to the sum of the remaining two adjacent sides. This is why it is called triangle inequality. And z1 z2 modulus will be z1 dot z2 and e raised to the power theta mod equal to 1. Now argument of z1 z2 will always equal to argument of z1 plus argument of z2, that is theta 1 plus theta 2. Remember it. From where it is coming? Here. Use this formula. Don't use x plus iota y to solve this. We will use r e raised to power iota theta in order to determine z1 by z2, z1 dot z2, etc. So what will be z1 dot z2? r1 r2 e raised to power theta 1 plus theta 2. So what will be the argument? Theta 1 plus theta 2, and z1 plus z1 by z2 equal to z1 by z2. Argument of z1 by z2 equal to argument of z1 minus ला जाएगा यहाँ पे, the minus sign will be come here. So argument z1 minus argument of z2 equal to theta 1 minus theta 2. Now if z equal to r cos theta plus iota sin theta, simply r e raised to the power iota theta is there. So if we raise power to the n, so whole power will be n, and when we open it, what will be there? Cosine theta plus iota sin n theta, and n will expand like this. So when you do z raised to the power 1 by n, so it will be r raised to the power 1 by n cos theta iota sin theta raised to the power 1 by n. Okay, always remember the value of z, r cos theta plus iota sin theta. So when you do z raised to the power 1 by n, it will be r1 by n cos theta plus, very important, always remember this term. You will need it to solve the questions, numericals. So when you are going to determine z equals to 1 by n, what will you do? R raised to 1 by n cos theta plus 2 pi k by n, and here also theta plus 2 pi k by n, and k is 0 1 2 3 dot n minus 2 up to the n minus 1 n term, n minus 1 term. and when you will raise the power to the n of this term, so what will you will get z. Okay, so you can say z raised to power 1 by n is the nth root of z. Very important, है ना. What is z to power 1 by n? It is the nth root of z. It will be clear with this question. Find the nth root of z equal to 1. We know z equal to 1. How will we represent z equal to 1? R equal to 1 and cos 0 plus iota sin 0. Cos 0 is 1 and sin 0 is 0. So we can write z equal to 1 like this. And when we raise to the power 1 by n, so what we'll have? We are having cos 0 plus iota sin 0 raised to the power 1 by n. And we just have done this. Z raised to the power 1 by n will be equal to cos theta plus 2 pi k by n. So theta is 0. So 2 pi k by n. Here also 2 pi k by n. And it is represented by omega n k. So what is omega n k? It is representing is z equal to 1 by n. And what is z 1 by n? R raised to the power 1 by n cos theta plus 2 pi k by n plus iota sin theta plus 2 pi k by n. Very simple. So when you put k equal to 1, you will get omega n. When you put any k equal to 2, omega n2 and omega n3, and just like that, omega n term will be equal to z. How it will be equal to z? Because z raised to 1 by z to the power n will equal to z. Very simple. You just have done this. Now find the 3 cube roots of z. Okay, we have to find out 3 cube roots of z. We know z raised to the power 1 by n also represented omega n raised to the power k cos theta plus 2 pi k by n. Theta is 0, है ना. Theta is 0 because we have done this earlier. Z equal to 1, theta is 0, and we have to find out the cube roots. So will be 3. Put k equal to 1, so we will get omega n cos 2 pi by 3 plus iota sin 2 pi by 3. So cos 120 equal to minus 1 by 2 plus iota sin 120 equal to under 3 by 2. If you know this, how to calculate it is very good. I am explaining again if you don't know. So cos 120 can be written as cos 90 plus 30. Cos 90 plus 30 will be sin 30, but it is in second quadrant. So second quadrant it will be negative because here is cos. So what will you have? You have minus 1 by 2. Simply write down here. And sin 120, sin 90 plus 30 will be cos 30. And in second quadrant is there, sin is positive. So cos 30 equal to sin 60 under 3 by 2. Put k equal to 2. So you will get cos theta plus 2 pi k by n. Theta is 0, 2 pi k by n. N is 3 and 2 pi k is 2. So 4 pi by 3, 4 pi by 3. When k equal to 3, then will be 6 pi. Now cos 4 pi by 3. What is cos 4 pi by 3? If you know, it is very good. Don't know, then I am explaining again. Cos 240 equal to cos 180 plus 60. Which quadrant? Third quadrant, है ना. So in third quadrant, cos 180 plus 60 equal to cos 60 and minus cos 60, because in third quadrant cos will be negative. So minus 1 by 2 will be there. And sin 240 will be sin 180 plus 60. So it will be minus sin 60 because in 180 plus 60 is third quadrant. So minus sin 60 and minus under 3 by 2. This is like this. And cos 6 pi by 3, which is cos 2 pi, and iota sin 2 pi. Cos 2 pi will be 1, sin 2 pi will be 0. So we'll get values like this. Now find cube roots of z equal to minus 1. So for z equal to minus 1, cos pi plus iota sin pi. Omega n k equal to cos pi plus iota sin pi 1 by n. Z raised to the power 1 by n. So we just have studied it. How we will expand it? Cos theta plus 2 pi k by n. And what is theta here? Theta is cos pi here. Pi plus 2 pi k by n. Here pi plus 2 pi k by n. So simply, in order to find cube roots, firstly put k equal to 1. So when k equal to 1, it is 3 pi by 3. So simply cos pi minus 1. 5 pi by 3, sin 5 pi by 3. What is sin pi 5 pi by 3? 300 degree. Okay. If you know the value, it is good. If you don't know, 360 minus 60. Fourth quadrant. In fourth quadrant, cos will be there. So cos is positive, 1 by 2. And sin will be negative. minus under root 3 by 2. So what we are having, 1 by 2 and minus under root 3 by 2 will be there. When you put n equal to 3, so it will be 6 pi plus pi, 7 pi by 3 plus iota 7 pi by 3. And what is 7 pi by 3? Charge 420 degree. And what is 420 degree will be equal to sine 360 plus 60. And sine 360 plus 60 will be sine 60. So sine 60 will be 1 by 2 plus iota under root 3 by 2. Now find the 4 roots of z equal to minus 1. For z equal to minus 1, cos pi plus iota sine pi. And when you do z equal to 1 by n, so cos pi plus iota sine 1 by n. And since we are determining 4 cube roots, so n equal to 4. Here also n equal to 4. And theta plus 2 pi k by n. So theta is pi. Pi plus 2 pi k by n. For k equal to 1, it will be 3 pi by 4. 3 pi by 4. And 3 by 4 is what will be 3 pi by 4. So you can say 3 pi by 4, 45 multiplied by 3, so 90 plus 45. So 9 cos 90 plus 45 will be sine 45. And in second quadrant, cos will be negative and minus under 1 by 2 will be there. Similarly for sine it will be positive. And for 5 pi by 4 you will do 4 pi by 4 is pi and plus pi by 4 also. So pi plus pi by 4, pi plus pi by 4. Which quadrant? Third quadrant. And third quadrant, cos pi by 4 will be negative. So minus 1 by under 2. Similarly, we will determine value for sin pi by 4. Cosine pi by 4 will be like this. So now we can calculate the cube roots of any complex function given to us. Now again there is one question more. We will discuss this. Suppose it is z equal to iota, then how will it determine z equal to iota? We know z can be written as r raised to the power 1, which is 1. Here r is 1 and e to the power iota theta, and theta is here. You will use pi by 2 because cos pi by 2 is 0 and here sin pi by 2 1. So we are left with iota that is given to us. So now next our process will be z equal to 1 by n. So z equal to 1 by n will be 1 by n. Cos theta plus 2 pi k by n. Theta is pi by 2 and similarly with sine. So when we will put k equal to 1 and n equal to 3. So pi by 2 plus 2 pi. So 4 pi by plus 5 pi by 2 multiplied by 3, 6. 5 pi by 6. Similarly 9 pi by 6 and 13 pi by 6. Now cos 5 pi by 6, what will be there? 150 degree. And 150 equal to 180 minus 30. 180 minus 30 will be second quadrant. In second quadrant, cos will be negative. So minus under root 3 by 2, sine will be positive. So positive will be there. And 5 pi by 6, 9 pi by 6. 270 degree. 270, 0. And sine 270, 1. Similarly as 90. And 13 pi by 6 will be like this. Okay. You can say if real and complex all are present, then cos theta plus iota sin theta. So you can say theta, first of all calculate theta. Theta is 10 is 4 by 3 and we know it is 53 degree. And it will be very complex. So in order your competition examination, it is very good chances that he will not ask about these questions, because if he is going to ask, examiner is going to ask you this question, then he has to give you various kind of values of degrees, angles with degrees. So most probably he will not ask you this. He will only ask you the above questions just we have discussed. So z equal to r is under root 4 square plus 3 square will be 5. So always remember or is also there, you know. Generally r is given to 1, so we are not writing it down, but r is always there. So in this question you have to remember this is like this. So cos 50 plus iota sin 53, when you will do, you will get like this, and z equal to r raised to power 1 cos theta plus 2 pi k by sin theta. So you can solve it further. I hadn't solved it. We can solve it now. Just we have to put the values of k, okay, and you will get the answer. But for solving this, you have to know the values of 53 plus 2 pi, k equal to 1. So 53 plus 2 pi with 360 plus 53, which is 413 degree, है ना? So this value you must know. It is hypothetical question, or maybe it has been asked in some other competition examination. Yes, I don't have the values of those degrees, that's why I have not solved this question yet. Now we'll discuss about the locus point of any complex function. Suppose it is written here z equal to 2. So you will solve it. Z equal to 2. What you are left with? You are left with x square plus y square equal to 4. Very simple is that. Under root x square plus y square z equal to, and when you square this term, it will be 4r square. So it is representing circle of radius to centered at the origin. So when you are going through z minus 2 equal to 3, so what is it representing? It is representing the circle of radius 3 centered at 2 comma 0. Okay, you can solve it like this. So it is, when you do it square, you are having this. So it has center 2 comma 0 and radius is 3. This is the standard form of the circle. So circle of radius 3 and center 2 comma 0. This is the locus point will be there. Suppose examiner has asked about z minus 2 iota modulus equal to r, at z minus 2 plus 3 iota equal to r, and z minus z1 equal to r. So radius is r and center is x1 comma y1. Here radius is r and center is 2 comma 3. You can see here. Here radius is r and center is 0 comma 2. Okay, you have to know this information is hidden in this equation. So by looking at this equation, you must find out that what is this equation is representing. Okay, so this equation is representing simply radius and its center. Now if we have this equation, z upon z minus 1 modulus equal to 6, so when you solve it, it will be like, it will go like this. When you square it, x square plus y square 36, x minus 1 square plus y square. Okay, now solve it. We are left with this. Now we have to solve it. In root solve it, what will you do? You will simply do x plus y whole square. So just coefficient of x, do it half of it and square it. Okay, here 35 will be divided with all these factors. So we are having coefficient of x is 72 by 35. So just half it. So half of 72 by 35 will 36 by 35. Now add and subtract this term. So when you add and subtract this term, it will be like this, goes like this, x minus 36 by 35 whole square till this, and when you solve it, it will goes like this. So what is it representing? It is representing under root 6 by 35 is radius of the circle, and center of the circle is 36 by 35 comma 0. Now suppose we have logarithmic functions, z equal to r raised to power e raised to power theta. So simply take log. So log r plus log e raised to power theta. So I will be there because log e base e is 1. You know this. So when you anti-log this, so e raised to power log and z equal to z. You know it very well, and it will be r raised to power theta. So from where we are using r raised to power r dot e raised to power theta equal to z. From here we were using this. Okay, so it's like the proof that z equal to r raised to power e dot r dot e raised to power iota theta. So log z will be log r plus iota theta. Very simple as that. Now this is very important. Why it is very important? Because if z raised to power a, then you must know that z raised to the power a will be equal to e a log n z ln z. Okay, z raised to the power a will be e ln z raised to the power a, and a will be coming in front side. Z e raised to the power z, j to the power a, whole power a, and a will be coming here. So find the principal value of z equal to 2 plus iota 1 minus iota. So it is z and it is power a, so z to power a, okay, and a is like this. So z raised to the power a is e raised to the power a ln z. So e raised to the power a and ln z, okay. And what is ln z? Ln z equal to 1 x square plus y square, okay, plus iota. Ln z equal to ln r plus iota theta. Ln z equal to ln r plus iota theta. So it will grow smoothly like this. When you solve it, you will get like this. And in question, examiner will give you the values of this. If the calculator is not allowed, then you have to give these values in order to solve this question, okay. So final answer will be this. Similarly, if you have to find sin inverse z, what will be sin inverse z? Minus iota ln iota z plus 1 minus z square raised to power 1 by 2. It is inverse trigonometric functions. You must have studied in your BSc also. Now we will discuss about analyticity of the function, okay. Now we will discuss about analyticity of the function. Suppose we have the function y equal to f of x. So there are three things which have to be true in order to determine the condition for analyticity for any given function. Suppose function must be defined, means function has to be with finite value, okay, and function must be continuous within the domain, okay. What is the domain? If function is f of a, suppose function is defined at a, then when we are putting the limit x, just x equal to minus a and x equal to plus a, so function have the value of f equal to minus a and f of a plus a same as f of a. There should not be any drastical change in the value of the function. So function must be continuous. And what is domain? Domain is the basically set of values, you know, y equal to f of x, है ना, 1 1 1 2 and all this you must have studied in your 12th class. So set of values of x for which function is defined, it is called domain. So functions must be have finite value, that is function must be defined on any point within the domain. Function must be continuous and function must be differentiable. This is the definition of differentiability, condition of differentiability. And you can determine differentiability by just looking at the curve. If the curve is not having the sharp edge, then curve is what? Differentiable. And suppose example is given here, f(x) equal to 1 upon 1 minus x, and you can see x equal to 1, function is 1 by 0 equal to infinite, so function is not defined at s equal to 1. Now you have a theorem, the necessary and sufficient condition for the derivative of any function will be f z equal to u plus iota v. Now to exist this function f of z, okay, for all values of z in a region R. Suppose we have a region R and this is the function. So to exist this condition, function must be derivative. So condition to be a function is derivative within certain range. What is the condition? This is the Cauchy-Riemann equations. Function means first derivative of del u by del x, del u by del y, है ना, real and first derivative of real and imaginary part should be continuous, okay. And this condition must be true. What is the condition? Del u by del x equal to del u v by del y and del u by del y equal to minus del u by del x. So if these two conditions are satisfied, then function will be derivable in the range. A function f of z which is single valued and possesses a unique derivative with respect to z at all points of region R is called analytic function or a regular function of z within that region. What does it mean? Means if you have a function f, and if this function is satisfying these two equations, okay, and function is single valued and function has a unique derivative also, then we will call function is analytic within that domain, within that range. Okay, so to be analytic for a function, there are certain condition. What is the condition? Function must be single valued, function must be continuous, and function must satisfy this condition, so it will be derivable. Okay, these are condition for derivative, and these are the condition for analytic. Now CR equations in Euler form, you have to remember it. Del u by del r equal to 1 by r del v by del theta, and del u by del theta will be minus r del v by del theta, del v by del r. Okay, so simply we are changing the variables, and here we are just del u by del x equal to del u by del v by del y, and del u by del y equal to minus del u by del x. Similarly in polar form, del u by del r equal to 1 upon r del v by del theta, and del u by del theta will be minus r del v by del r. You have to remember, just revise 2-3 times, and automatically these things will be fed up in your mind. So if we double differentiate this equation, we will get this. So you are led to Laplace equation del u by del 2 u by 0. Similarly with v del 2 v by 0. So you can say those functions which are satisfying Laplace equation are called harmonic function, and harmonic function will be derivable also. Now we are not here. The real and imaginary parts of an analytic function always satisfy the Laplace equation and are known as conjugate harmonic function. Okay, so if we have analytic function, and we know analytic functions have real and imaginary part, and that real and imaginary part will always satisfy Laplace equation, and it is known as conjugate harmonic function. Okay, now we are going to check analyticity of the following functions. What is z bar? Simply z bar is equal to z square. It is under x square plus y square equal to x square. Okay, so simply do Cauchy-Riemann equations, del u by del x to x, del u by del y. So it is nowhere analytic. Okay, if z square, simply z square is a polynomial, and polynomial of any degree will always have analytic function. Is it to power 8 is single valued continuous, and it is analytic, differentiable also, because there is no sudden change. Log z is also analytic everywhere, and sin z is also analytic everywhere. This is the function y equal to mod x. So it will go like this. This is not, the function is not having any sharp edges except x equal to 0. So at x equal to 0 it is not differentiable. Now we have tan inverse x graph pi by 2 to pi by 2. It will go smoothly. There is no sharp edges. So minus pi by 2 open interval, minus pi by 2 pi by 2, it is differentiable. If we are doing closed interval, this is not differential. Because at minus pi by 2, if we have theta equal to minus pi by 2, then it will goes to infinity. You know this all things. You are very smart people, I know. So z equal to x plus iota y ka whole square. So when you expand it, you will get like this. So just differentiate this with respect to z. So what you have? You have x plus iota y, u plus iota v. So del u by del x plus iota del u by del x. So it will goes to 2z, and del u by del x equal to 2x plus del u by del x equal to 2 iota y. This is u and this is v. So you are going to 2z e raised to power z equal to e raised to power x dot e raised to power y. This is u, this is v. Just 2 del u by del x plus iota del u by del x. You are leading to the same function. Now complex integration. We will now study about complex integration. We will do this in our next class. Okay, thank you very much.